everyone. In today's video we are going to see about electrochemical cell, which is also called as galvanic cell. Okay, this is the most important concept in the chemistry as well. Yeah, first let's see what is this galvanic cell. Means it is a device in which the chemical energy will be converted to the electrical energy. That means based on some chemical reactions, based on some exchange of the electrons and protons and their charges from one end to other end, they will produce the electrical energy. This is what we use in our daily life as well. Okay, in the batteries we will talk about those later, and for now I'm just telling the basic application of this. Okay, the conversion of chemical energy to electrical energy is called as electrochemical cell or galvanic cell. Now these cells are called as electrochemical cells or voltaic cells. Okay, these are the names of it: electrochemical cell, galvanic cell, or electrochemical cells, or voltaic cells. Okay, all these are nothing but only same one only. Now in this we will see example of Daniel cell. So these type of cells are called as electrochemical cells. In electrochemical cells we have one example called as Daniel cell. We will see about the complete operation and how this process will go, and how the electrons will change from move from one end to other end in presence of what substance, and how they will produce electricity will be seeing in this detail. Okay, first what happens, let's now this complete picture is a diagram of the galvanic cell. Okay, in galvanic cell this complete cell is made up of two half cells. Okay, first one is zinc, second one is made up of copper. Okay, one is for the oxidation or anodic half cell. Okay, that is called as oxidation or anodic half cell, and the other one is reduction or cathodic half cell. Now the first cell will contain zinc electrode. Okay, zinc electrode which is dipped in the ZnSO4 zinc sulfate solution. Okay, this is first cell is dipped in zinc sulfate solution, and the second cell which is also made up of copper, this is dipped in the copper sulfate solution. Okay, that means this complete cell is in the zinc sulfate. This is complete whatever the solution is there, this is zinc sulfate, and here it is copper sulfate. Okay, these two are dipped in the respective solutions. Now both these cells are connected by the metallic conductor. So this is what metallic conductor. These two are connected to from here and from here. These two are connected using the metallic conductor to a bulb. Okay, such that when the electricity, how we know that electricity is produced means whenever this bulb lightens up, that is how we will can know that the electricity is produced from the chemical energy. So what are all these? These are chemicals. Now we should make sure that chemical energy is producing the electrical energy. That means only when the bulb is glowed. Now how this happens? Okay, now to separate these two solutions we have one salt bridge. Okay, this acts as a membrane. Okay, this acts as a membrane. This membrane, or you can say salt bridge, contains KCl or NH4NO3. Okay, this salt membrane is made up of potassium chloride or NH4NO3 in the which is dipped in the agar gel. Okay, whatever this membrane, we will call it as salt bridge. Okay, this will act as a membrane between these two. That means it will pass the ions from one side to the other side. That is the property of membrane, right? It will pass from one pass electrons or charges or whatever we want to pass through it. We will use a membrane. Now this salt bridge is made up of KCl or NH4NO3, and this is dipped in the agar gel. Just like zinc is dipped in zinc sulfate, here also this salt bridge is made up of this, and it is dipped in the agar solutions. Now this is placed in between the two cells. Okay, this is what the salt bridge what I am explaining you till now. Okay, this act as a separator as well. These are the different, the main key point. You will get 2 marks answer also, 2 marks question also, like what is the use of salt bridge and what it is made up of. So you will get those questions as well. The salt bridge is made up of KCl or NH4NO3 and which is dipped in the agar-agar gel. Okay, this is what complete diagram and what is happening here completely. Now we will go through it with some reactions. Okay, now at anode side, zinc will loses Zn plus 2 plus 2 electrons. The process of losing electrons is known as oxidation. What is oxidation? The process of losing electrons is called as oxidation, and the process of gaining electrons, it is known as reduction. Reduction here occurring at the cathode side and oxidation is occurring at the anode side. Okay, in the figure we have, this is zinc part is anode, copper part is cathode. Okay, this negative part and this is positive part. That is what, okay, these reactions will take. At anode side, what happens? Zinc will release 2 electrons, and copper, what it will take, whatever the electrons released by the zinc, it will take those 2 electrons and it will result in the Cu. Okay, this is reduction. This is what the complete reduction is going on. Now what happens upon this losing electrons and again taking these electrons means the complete reaction is this: Zn, pure Zn plus Cu plus 2. That means copper which is in need of 2 electrons. That means it is like searching for the electrons, 2 electrons on reaction. That means on that electrolyte and all those things. We have, it will, what happens is it will release 2 electrons. That means Zn will release 2 electrons, and whatever the released by this Zn, it is absorbed by the copper. So it will produce Zn plus 2 and Cu. This is the complete reaction or the complete process is going on. Now, how can a galvanic cell represent it? See, instead of explaining this complete process, you can just write this equation. Okay, at last. So this, what it will say is, okay, there is this is a galvanic cell representation. That means zinc is dipped in the zinc sulfate, and copper sulfate in the copper rod is dipped in the copper sulfate solution, and this is a salt bridge representation. Okay, this is what the complete representation of galvanic cell is. Now the passage of electrons from one electrode to other electrode will cause a potential difference from them. Potential difference means the voltage difference in them. That is called as EMF. EMF in complete is electromotive force. Okay, when this electromotive force is generated or produced, the bulb will glow, whatever we have here. Okay, when this zinc loses 2 electrons, it will send here, and copper will absorb those 2 electrons. Now upon this passage, like continuously it happens, not once. The complete reaction will happen continuously, okay, until both the charges on both sides are balanced. That means the zinc will not be able to lose the electrons further, and the copper will not be able to absorb the electrons further. So until that, there will be process of the electrons moving from one electrode to the other electrode. So when this movement occurs, the electricity is produced and the bulb will be glowed. This is how the complete process will happen in the galvanic cell. Not just this cell, in every cell, this is the basic phenomena. In any other concept you take, in which is related to batteries or cells, you will have 2 electrodes like this and one separator for these 2 electrodes, and then they are dipped in some solutions, and because of the solutions and their electrons losing capacity and gaining capacity, the movement of electrons takes place, and we will get the electricity. The same phenomena will be happened in every other cells as well. Only the difference is in each cell, each solution or each electrode we will use. So in this galvanic cell we used zinc and copper. In the other cell we will use some other two elements. So that is the difference only, but not the process. Okay, that's all for this. Thank you.